All right, so object-oriented programming. This is a new unit that we're moving into, and we'll kind of merge the ideas of the last couple of units where we're thinking about data analysis and object-oriented programming very soon. But let's talk about object-oriented programming in isolation. So I want to set up a sort of a motivating example for what object-oriented programming is all about. And it's a different kind of programming paradigm than we've been using so far. Up until now, you would call the types of programming we've been doing kind of procedural programming or imperative programming, where we're thinking in terms of breaking our problems down into just functions. And pretty soon, we're going to see that there's another way to sort of organize some of our concepts, and we start to develop classes and objects. To make some sense of what classes and objects are and to just provide an example, what I want to do is turn our imagination and thoughts towards a concept that is very familiar from our early primary school days. The idea of Cartesian coordinates, right? And we've got let's imagine an axis here with this being our x-axis and this being our y-axis. And one of the things that you can imagine is, you've got a point that's say like right here, and maybe another point that's here. And these points have different attributes related to them, right? Let's imagine, I'm just gonna fill in some numbers here. Let's call this like say 2 on the x-axis, and this is maybe 4. And let's say this is, 5 on the y-axis, and this is maybe -1, right? So when we think about these points, well, what is a point in a 2D coordinate plane? Well, it's sort of the combination of a grouping of two values, right? We've got an x attribute and a y attribute, and we're grouping these two attributes together. So we might think of this as, the coordinate 4, 5, and this as 2, -1, where there's this sort of convention of the way that we represent a point in text when we're thinking about, okay, here's the idea of a point in a graphical nature, but in text, we're going to list the number of the x-axis first and then the y-axis second, right? So hopefully nothing too out of the ordinary here, but if we think about how might we model a point given the concepts we have available right now? Well, we've got, we could have two variables, like two float variables that are sort of unrelated to one another in general, but we can treat them as like, okay, these are, we could have a variable that's like x1, or if we were writing this in Python, x1, x2, or sorry, x1, y1, and x2, y2. And, there's some downsides to having just a bunch of variables that are kind of organized in this sort of haphazard way. Now that we know lists, you could also imagine maybe having a point be represented as a list that has two items in it, where this might be the list 4, 5. The first point is 4, 5, and the second point might be 2, -1. But there's some downsides to thinking about points as lists as well, right? Like a list has other meanings just sort of associated with it. It's not really a point. It's a list, and you can append to a list. You can pop from a list. Those are operations that you wouldn't expect to carry out on a point. And a point, in turn, is going to have operations that you might be able to carry out that you wouldn't expect on a list, such as maybe finding the distance between 2 points, or inverting a point by flipping its axes, or maybe a reflection among like one of the axes, a y reflection or an x reflection, or you could imagine asking a point what coordinate is it in. So you can think of point. The idea of a point is that it's going to have different capabilities associated with it. So if we try and, you could also imagine doing this with a dictionary, right? Where you could have one dictionary that has like an X property of its X coordinate, and a Y, or a Y key with its Y coordinate, something like this. But similarly to lists, there's some trade-offs here where, a dictionary isn't really a point. We can force it to be, and we can like kind of wave our hands and say, okay, we're going to treat it as if it's a point. But if we're really trying to model the idea of a point, we'd like to have something that is actually a point, and a point data type. And what would that point data type be made of? Well, that's what we're going to explore today, how we can model concepts using ideas that we come up with. And so with object-oriented programming, we're going to see that we can invent data types. And so a class is going to give us the ability to come up with our own data types. So a class specifies a new data type. All right. And when we think of a point, we can think of a point as an example of a class. So a point is an example of a class. And I should actually say, I'm not going to say a point. Let's actually call this the idea of a point. And this is a little sloppy, but the idea of a point is an example of a class, right? So what do I mean by this? Well, any point, rather than, let's say I could put the name A on this point and the name B on this point. When we think about a point in general, it's just something that has two attributes, an X attribute and a Y attribute. But we can think about specific points. Like here, there's a specific point A whose X attribute is 4 and whose Y attribute is 5. And this is a specific point B whose X is 2 and Y is -1. And so there's this difference between the idea of something, and that's what we're going to call a class, and an actual example of it, or an instance of it, or an object is what we'll see it's called in object-oriented programming. So the idea of a point is an example of a class, and a specific point is an object. And you're going to see the word object or instance used interchangeably. All right. So there's this distinction. And we ask, well, what actually is a class, or the idea of what we're trying to model here? And as we've just mentioned, we started off by thinking, well, it's kind of like we have these related variables. And what a class is going to do is it's going to allow us to group some related variables together. We're going to call those attributes. So attributes are another important concept that we'll look at how to define in just a moment. And attributes are a group of related variables that make up a class, that are defined on a class, and make up an object. And this distinction we'll talk about in just a moment. All right. So let me try and, this is some pretty abstract terminology here. If we're trying to be a little bit, bring it back to our example. So the idea of a point is going to have attributes, and I'm going to shorthand this just attrs. And let's say it has attributes X, which is a float, and attribute Y, which is also a float. And what we're saying when we define a point class is this is the idea of a point, right? Every point is going to be made up of two attributes, an X attribute and a Y attribute. But this isn't actually a point yet, right? We don't have a value that we can work with. We haven't constructed any objects. And so if we were to imagine, well, what is this specific point A? Well, you would say that's a point object whose values are 4 and 5, right? So the other thing that classes are made of, which we'll come back to in just a bit, is our methods. And these are like the operations that you can carry out on objects. So we could ask a point, what quadrant are you in? Or we could ask a point to invert itself. Or we could ask 2 points, what's the distance between these two things? So let's make some of this a little bit more concrete and jump into VS Code. Now I'd love for you to follow along with this. And then after we get an initial example here, we'll move to questions. So I'm going to start a new example lesson, or new Python script. This will be ls21 classes objects.py. Right? And let's go ahead and add our doc string, which is examples of object-oriented programming concepts. All right. And I'm going to go ahead and get some example syntax on the screen here, and then we're going to talk through exactly what's going on and how we arrived at it and what it is that we're looking at. So we're going to define our very first class, and it's going to be this idea of a point. Right? So we're going to use the keyword class. And this is a special reserved word, just like def is, just like if and else are. This is built into the Python language. And following class, we're saying I'm defining a class and its name is going to be point. We could have named this class anything we wanted. This is an identifier, just like the names of variables and functions. But typically when we define classes, we use an uppercase letter as the very first letter. And so this sort of establishes the idea of the class as, a proper idea in our program is one way to think about it. And it makes it easier for us to distinguish, the name of a class from, say, the name of a variable or a function, which we would typically start naming with lowercase letters. These are just conventions that programmers have kind of rallied around in order to make it easier to read our code. So what is a class? Well, we said a class is going to be made up of attributes, and a point has 2 attributes. And we think of these as sort of like grouped variables. And when we define them, they're going to look like grouped variables. So x is a floating point, and x is just going to be a floating point attribute, and y is also a floating point attribute. What if, for example purposes, and we'll develop this and see a few iterations of this, we wanted the starting point to be the origin, or 0, 0. Well, we can assign initial default values to each of these attributes, right? And I might go ahead and just make a comment here, defining attributes, related variables of a class. All right. Now notice there's a level of indentation, and as you're hopefully becoming comfortable with in Python, when we indent, a block of code, what we're saying is these declarations actually belong to this class point. All right. Now again, this is just the idea of a point. We don't actually have any real points, in our code defined. So what I think is going to make sense for us to do is imagine that we're the Python language and we're trying to interpret this program as it's written here. Because sometimes you see something like this and you don't really know, well, what's going on in memory? And since we have this shared vocabulary of a memory diagram, what I'd like to do is just start off by showing you, if this was the program that we had written so far, how would we represent it in memory? Well, as you know, we're going to have a stack and a heap. And stack is going to have a globals frame. All right. As we're comfortable with, docstring doesn't do anything. So all that matters is what happens when we reach a class definition, which is what we're seeing here. Well, it's just like encountering a function definition. We're not going to really do anything with this quite yet. What we're going to do is remember, hey, we are defining the idea of a point. You'll be able to use point later, but let's record this idea that, okay, in globals, we now know that the word point is associated not with a function on our heap, but with a class on our heap. And the definition of that class can be found on lines 3 through 8 currently. We'll change this in just a moment as we add more to our class. All right. And so this is our program thus far. This idea that there are X and Y attributes that are sort of embedded in the idea of a point, they're not really going to matter until we create a point that we can work with, right? We're going to have 2 points, A and B, and we'll use those same coordinates we started out with, right? So far, all we've done is defined the idea of a class as something that's made up of 2 attributes when you actually have an object whose type is point. So let's actually try making a couple points. And for our purposes, we'll name them A and B. All right, so I'm going to hide my annotations here for just a moment. And I'm not going to use a main function. Just so this example is straightforward and we keep everything in globals, I'm going to just go ahead and set up a point object here. And it's going to be assigned a new point, right? And I'm going to go ahead and try and recall. So A was 4, 5. So A dot X attribute is 4 and A dot Y attribute is 5.0. And there was another point B. And we'll talk through what each of these lines is doing in just a moment. B dot X was 2, I believe. Yep, 2 and -1. All right. So we've added a few more lines of code here. And if we go back to our diagram, we've got some new concepts to understand. Well, what's actually going on here? We're going to spend quite a bit of time today talking about this particular function call. It's a special function call. Notice that on line 12, we're calling a function whose name is the same as this class. This is actually going to call start what's called the constructor. And this is a process we'll talk about in just a moment, but ultimately it's going to result in a new object on our heap. And I'll show you that in just a moment. Before we get there, there's one other kind of funny thing that we need to talk about. Notice the type of this variable, A. We're saying A is a point type. And that's pretty cool, right? Like we just invented a few lines above a brand new data type that didn't exist before. We came up with this on our own and we said, hey, in our program, we want to be working with the idea of 2D points. So we're going to invent this data type called point and say that it's made up of these 2 attributes. Every point is going to have an X attribute and a Y attribute, and they're both floating points, all right? We then went on to initialize those, but before we worry about lines 13 and 14, let's just talk about, well, what happens in memory on line 12? Well, when the constructor is called, the simplest thing to understand that happens when a new object is constructed, and this is when we call a function whose name is the same as a class, is we need to set up a point object on our heap. So point is an object, and because we defined it has 2 attributes, X and Y, we're going to say it has 2 attributes in memory. And we think of this, it looks a lot like how we represented a dictionary. But notice that the type isn't like a dictionary from string to float. This is its own type. Point is this type that we just invented, right? And A is going to refer to this point object, right? So now we have a brand new point. And by default, its 2 attributes, X and Y, were established and initialized to be 0 because that's how we define those attributes. And now on lines 13 and 14, we're saying, hey, let's actually assign different values to each of these attributes. So we've seen this syntax before where you have like the name of a variable and then a dot. And then we've seen method calls like a list.append or list.pop. This is accessing an attribute. So notice we're saying a.x. Well, A, we follow that arrow. X is this attribute right here. And this is an assignment statement. So we're saying store 4.0 in a.x. So a.x is this attribute. So it's going to be changed to 4.0. And a.y is going to be assigned 5.0. Same idea, right? So just to carry this forward and set up B, and then I'll take questions. Let's finish out this little program listing before we add some additional concepts here. So again, we see that B is going to be assigned a brand new point. When you see a function call where the name of the function, and you look up what is the name of this, what is point? So you look in your stack and look in globals and you see point, oh, that's bound to a class. When you call a function that's like a class, we're going to set up a new object. And this is called a constructor call. All right, so we're constructing a new object, which just means we're setting its space up in the heap. So point and x and y, and because its attributes were 0 and 0, those are set up automatically for us. Right, so now we have 2 points in memory, and notice these are both objects, right? So we would think of these two values in the heap as objects whose type are point. And then remember, class is the idea of a point, right? On lines 17 and 18, b.x is, oh, I didn't set up b. So b is going to refer to this second point. And notice with object-oriented programming, whenever we have an object, we're going to have a reference to that object. So everything we learned about references when we were working with lists and dictionaries is going to apply here as well. The same things that we need to be careful with references, we'll need to be careful with objects. So b.x is 2.0 and b.y is negative 1.0. So these were modifying those attributes, right? And so now we've got this setup where after this program is run, this is our state in memory. We haven't actually made use of any of these things, right? We haven't printed any of this out. We haven't done anything useful with these points. But right now we're trying to emphasize what is the meaning of a class definition. And it's kind of like a function definition. It's establishing the idea of something, but we're not yet making use of it. It's not until you go and you construct an object of a class or an instance of a class that you can start to make use of it. One of the things that you'll notice right off the bat is that as soon as we constructed an object, it had the attributes of that class definition, right? So this class defined, every point is going to have an x and y attribute. So as soon as we construct a new point, it has x and y and attributes built into that object, and these are grouped related variables. You'll notice that we can have multiple instances of the same class, and this is an important distinction, right? So you'll have one class that has a specific name, and this is the idea of this grouping of attributes, and we're going to be able to add capabilities shortly. And once you have a class, you can make many objects who are of that class's type, right? So we can use that class's name as a data type, and we'll see that we can establish parameters to functions whose type is point, or return value types that are point as well. All right, so let me take some questions here. Do you have to assign attributes to specific values in the class? So this is a good question. Right now, what we're seeing is, we're defining a very simple class, and we haven't yet learned how can we make it such that as soon as we make a new class, or sorry, make a new object, it's going to have the attribute values automatically set up, like as part of, we want to make this step that we're seeing here where we're saying, okay, X and Y, it seems like every time we make a new point, we're going to want to specify what its X and Y attributes are. So pretty soon we're going to learn how to make that happen all in one step. But for now, the important part to know about attributes is that we have two attributes here, and every object of our class is going to have those two attributes associated with it. Why do you have to assign 0, 0 to both X and Y at the beginning? Can't we skip that step? That's a good question. Looking at this very simple example, you probably could, but if we hadn't had these lines here, right? And maybe not these either, you would want to know what are the actual values of the X and Y attributes for A and B. And the way that you would know that in looking at your diagram is to be certain that your diagram is reflective of what those values would be. And those values would be the default values 0, 0, right? So I would encourage, where there are values initially assigned to attributes, to go ahead and make that distinction. But we're going to see an improvement on this that I think gets at how to avoid this sort of double step happening in just a moment. All right. Do you have to assign attributes to specific values or specific values to attributes? No, we're going to see a way that we can actually have more flexibility here in just one moment. Are A and B both constructors? This is a good question. In this line of code, we know this is a variable declaration and initialization statement, right? So var decl and initialization, right? A is just the variable name. Point here is the data type. And this is what we would call a constructor call. So a constructor call looks just like a function call. The key difference is when you go and look in your diagram and say, hey, what is point actually? Notice this isn't a function we're calling, it's a class. And so there's this special convention that is when you call, when you set up one of these constructor calls, and it looks like a function call, but it's actually, you're calling the name of a class, a new object is established on the heap for you immediately. And we'll see there are some extra steps that might happen in just a moment. But for now, we just know that when you call a function with the same name as a class, we set up some space on the heap with all of the attributes already set up in that memory space as well. So there's a question of what happens when you print A or B. Let's try that in just one moment. I'm going to come right back to that question. Could you define a constructor call? Yeah, so we're going to be able to define a custom constructor, and that's going to be a function that gives us a little bit more control, and we'll see that in just one moment. There's a question of what is subscription notation for the point class? That's a great question. Right now, if we tried to use subscription notation, it wouldn't work. We would see that there's actually an error. So subscription notation is something that you can use with lists and dictionaries. And if you wanted to be able to use it with your own classes, there are special ways that you can define what we'll see are called methods in order to make that possible. And we'll actually look at that pretty soon. But right now, if we tried, let's actually try these last two questions really quickly, because these are instructive, and then we'll come back to defining our own constructor. So the first question was, what happens if you print A or B? So I'm going to print A and print B, and you don't need to, actually, it might be, yeah, we'll make this nicer in just a moment. So the lines that I added were 15 and 20. And if I were to try running this program, so Python lessons.ls21 classes objects, we're going to see something kind of funky, right? So I don't want to get too lost in the weeds of what we're seeing here, but I do want to try and give you a brief sense of what this is. Let me see if I can get back to having a pen here. All right, so let me erase some of these annotations and talk about what we're seeing here. All right, when we ran this program, remember when we used the if name of this module is equal to main, well, when we run a module as a program, main is saying this is the main module. This is where the program started. So that's all that is. Point is, and so we'd say that everything in main is actually going to be in our globals frame, right? Point is this class point. So we have a point object. And then this funky business over here is a memory address, right? So this is actually the address in our heap space of where these objects are. And notice that they're not the same. And this is important, right? So they're close, like a lot of the address is very similar. But when we look at the very end, we see that these two objects are at two different places, or in two different places in memory. And you could think of this as, as when we started this course, we said, memory is like a giant sort of cubby space, and every position in memory has an address associated with it. It's not until later on that we care about thinking about these addresses in a more sophisticated way. But really, if we were to go look, and you could imagine like, okay, this is 9100, and this is address 9190, and these are places in your computer's memory that have assigned memory addresses that we're seeing here. And we can just see that these two objects are stored at two different places. And yeah, so that's what you're seeing printed out, but that really doesn't seem very helpful, right? We've got to be able to do better than this. And by the end of today's lecture, we should be able to do better than this. We'd really like a much nicer representation, right? If we go back and think about our original example, the way that we represented a point, the idea of a point in text was just with its two coordinates and a comma between them. So we'd love to be able to represent our points in textual format in our programs in the same way. All right, so let's get back to the question of, can we define our own constructor? And can we set up, this two-step process of starting at 0, 0 and then reassigning to 4 and 5 feels like a lot of work. So we should be able to do better than this. So let's define our first constructor. So a constructor, this was calling a constructor, and every class is going to have a default constructor built into it as part of the Python programming language. And that's actually what is getting called. And then what Python says is, hey, if you define the special function inside of your class that's named init with double underscores surrounding it, right? So def underscore init underscore, right? And remember, this underscore notation gives us some sense that, oh, this is special to Python. It has special meaning. It's reserved. Python has some reserved meaning for this. And in this case, this is the constructor. And it's going to have this special parameter whose name is self and isn't going to have a type associated with it, because we'll see in just a moment that the type is always the same as the class itself. And it's not going to have a return type either, for reasons I'll talk about in just a moment. Right? We can define additional parameters, and we should go ahead and do that. So let's define an x parameter, which is float, and a y parameter, which is also float. So just like a function definition, we can define parameters to our constructor. And here we're going to do something funny that is going to look strange, and then we'll come back and talk about why this makes sense and how to think about this in terms of memory. What we're going to do is we're going to say, okay, assign to the object that's being constructed. So self is going to be a reference to the object being constructed. Self.x attribute is going to be assigned the x parameter, and self.y is going to be assigned the y parameter, right? I'm going to go ahead and remove these default values, 0, 0, from my attributes, right? And once you do this, and I might go ahead and make a note here, a docstring that construct a point by giving x and y arguments. Okay, so we've defined a constructor, and we're going to pump the brakes here in just a moment once we get to thinking about what's going on in memory to talk about what's going on here. But we don't have a valid program anymore. We've actually created some errors down below, and so you'll notice that on line 16, I've got an error. This constructor call is no longer valid. Well, why is that? Well, it's because we defined our own custom constructor that says, hey, you have to give me x and y that you want me to initialize this object with. So what we're going to do to make this correct is just go ahead and say 4.0 and 5.0, right? And I'm going to delete the lines below it. For B, I'm actually going to leave this 0.0 and 0.0 so that you have an example of how to assign to attributes, and we can make a comment here. So assign to attributes of an object. Right. All right. So we've changed our example, and let me just talk about what we have here before I go back to diagramming, because I'm sure many of you are still bringing your code back into alignment here. This init function also belongs to point. So notice it's at the same level of indentation. The def keyword is at the same level of indentation as our attributes. And what we've defined is a constructor definition. And you'll notice a lot of this looks exactly like a function definition. And it is a special kind of function that is defined inside of a class. And the purpose of a constructor is to initialize new objects. Right? So what does that mean? Well, when we make this constructor call, a sequence of steps is going to happen. And I think the best way to talk about those sequence of steps is to try and diagram them out, because now that we have diagrams, we can actually understand piece by piece what's going on in this constructor call. So I'm going to jump back to my diagram, and I'm actually going to erase some of the work that I had before. And imagine that we're back at line 15. Right? So all that's changed, or all that we've done in our program evaluation, is we've evaluated this class point, and that didn't change other than the lines did change. So class is now the class from lines 3 to 12. Right? So point is the class from lines 3 to 12. Right? And now we reach line 15, and we see a constructor call. But this one's different than we saw before for a couple of reasons. One, it has some arguments, right? 4.0 and 5.0. And two, now if we go and we look in our class point, we see that there's a special function defined that's a constructor. And you know that because of the name _init. In Python, in the Python programming language, the name of all constructors is going to be _ surrounds the word init. Other languages choose other conventions. This is just what Python chooses to designate. This is our constructor function. So when this constructor call occurs, we are going to evaluate this function definition. And the way this is going to look on our stack is going to be very similar to another function call with a few subtle differences. Right? So let's process what a constructor call looks like in our stack. I'm actually going to give myself a little bit more space here. Right? So when we call a constructor, we're going to put the name of the class that we're calling, so point, and then the name of the function through a convention is just going to follow the hashtag. Right? And we'll have some very detailed notes on this as we get more practice with diagramming object-oriented concepts. But the name of the class, hashtag, and then the name of the function that's being called, and this is init, which is the constructor. All right. Let me see if I can. All right. Now, the return address is going to be, as we expect, line 15. But we've got, when we go to set up our parameters in this frame, we've got a new problem here. What is this self keyword? So self is a special keyword that's going to be bound to a brand new point object, right? And because we got rid of those default values for X and Y in my example, so I erased, X is assigned 0 and Y is assigned 0 as default values for new point objects. We're going to leave those just empty, undefined. They're not assigned any meaning yet. So how did this happen? It feels like this is magic, and it is. So when you call a constructor, Python behind the scenes, outside of view of your own code, it reserves the space on the heap to store the attributes of your new object. And when you have a custom constructor called, the reason why we always define this self parameter in Python is because we need to pass in a reference to that point that was set up. So self is going to be a reference to this brand new point object that we're going to be able to work with and initialize, right? So remember, the point of a constructor is to initialize the attributes of an object. So let's keep moving here. So we've got this X attribute, which is going to be bound to 4.0 in this example, and this Y parameter, this X parameter 4.0, and this Y parameter is going to be 5.0, right? So we've established our return address, we've established our parameters, and the special step when we call a constructor is self is bound to some new object that we're ready to initialize. And now we're ready to jump into this constructor. So here, things work in a pretty straightforward way, right? We're saying take X. Well, the current frame that we're evaluating is this one, and X in that current frame is the value 4.0. So this is like saying 4.0 is being assigned to self.x. Well, self is bound to this point object, and this is X, and it's 4.0, right? Y is 5.0. Y is being assigned to self.y. So self.y is being assigned 5.0, right? And then there's something funny that happens, all right? So up until now, the special new things that we've learned about a constructor call are that we look in the class, see if there's a function named init defined, and if so, that means there's a constructor defined. You know, we changed how we titled our frame a little bit to say, okay, the point class, specifically its init function or constructor. And the reason for this is we can have many classes, right? We could have a line class, and it could also have a constructor whose name would also be init. And so we need to, now that we're dealing with classes that might have methods and constructors of the same name, we precede that name with the name of the class that it belongs to. And we set up self, all right? So now there's one more weird step. Well, how do we get back from the constructor to where we came from, and what is actually returned here? It seems like it kind of funny. This doesn't look like it's returning anything, but somehow this expression is going to result in a reference to this object we just set up, right? So what gives? Well, because the purpose of every constructor is to initialize an object and give you back a reference to that object, it would be pretty redundant to have to say, you know, return self. But effectively, every constructor, you should imagine, has this statement as the very last statement in it, right? And this isn't a statement we can make for reasons that are very Python specific, but you should assume that there's this implicit statement that's code you'll never see, but what Python's going to do is it's going to take from your init constructor and return that reference back to whoever called it, right? So the return value of this constructor call is going to be whatever self was. Well, self was a reference to this point, so now we're going to return that same point, right? So we're returning this point, a reference to the point with x4, y5. And where are we returning that to? We're returning that back to line 15. So this expression resulted in A being bound to this point, all right? And so this is what happens when we construct a new object and have a class that has a custom constructor defined. So this was our custom constructor. Let me pause here and take some questions. Could you think of self.x as subscription index to x? That's a, you could think of those as very similar things. I don't want you to, they are distinct in how you would read about them and how you would hear people talk about them. You won't hear me say self subscript x because in the Python language, self subscript x would be referring to square brackets like that. And you can do both of those things, right? We could, like, with a list, you can subscript the list with an index, and you can also access its methods with the dot. This is what we would call the dot operator. And the dot operator is separate and distinct from subscription and indexing, but they are conceptually very, very similar. And the one key thing that I think you're latching onto as feels like it's the same kind of idea, and you're absolutely right that that these things are very closely related to one another, is that when you see this dot, you're effectively following this reference, right? So when we see self.x, we're going to follow that arrow. So the dot is like saying, hey, go follow some arrow somewhere else into the heap. And the next thing that happens after that, the next thing that comes, like y here, y is going to be referring to something in that part of memory. And so y would refer specifically to this value that's 5. Will init be the only function defined within a class? No, we're going to add some capabilities in just a moment, and we call these methods to classes. Like maybe a very simple one will be, what if we wanted to invert x and y and effectively swap them? If we want to be able to invert a point, we might add a method for that. If we want to be able to represent a point as a string, we'll see that we'll add methods for that. So most classes are going to have many methods associated with them, not just one. We haven't actually seen a method yet, so I'm going to come back to what a method is and we'll explain that fully in just a moment. For now, all we've seen are attributes, which are the grouped related variables that every object of a class is going to have. And now we've just seen a custom constructor that when we go to initialize a brand new object, this is the function that helps set everything up and make sure that your attributes are ready to go. And so this is really nice because now we can, in one single constructor call, set up the x and the y attributes of our point so that we don't have to construct an object and then say a.x is 4, a.y is 5 on multiple statements. So notice what we improved in being able to add this constructor is much simpler initialization. So for every constructor call, we would add a new frame on the stack. Well, we would add another frame for B. That's right. So for our purposes, when we're diagramming these questions, as we're getting comfortable with the idea of the existence of a constructor, we will be adding frames for each of them. So we would add another. So if we continue this program on, we see this constructor call, we would set up a frame for B just the same way. I'm not going to go through all of that here because I want to get to methods. But yes, it would be the same series of steps. In B's case, it would ultimately result in a point that had x and y of 0 and 0. Oops. Point object whose x and y are 0 and 0 initially. And the reason why I kept this B example in the way that I did was so that we could have in our notes a way of being sure that, we can still see that we can assign b.x is 2. So this next line changes to 2 and b.y to -1, right? One other thing that we should add before we go and look at methods is accessing these attributes directly. So we tried printing A. Well, what if we tried printing a.x and print a.y? Just to convince ourselves that this is an expression that will evaluate to the value stored in A's x attribute, and this will evaluate to the value stored in A's y attribute. So if I were to run this program again, we see that 4.0 and 5.0 are as what we would expect showing up. All right. Is self a built-in variable? What is it doing? Yes. Self is a special concept that is built into the language. And when you evaluate a constructor, it's going to be bound to a new object on the heap such that it's ready to have its attributes assigned new values. All right. So Python, when we call this constructor, behind the scenes, clears some space in memory and says, okay, this is going to be where our point object is going to live. And it gives you back a reference to that so that inside your constructor, you can initialize the attributes of that object. We'll see with methods, it's going to look a little bit different. So I want to get there next. But let me just take this last question on constructors, because this is a great question. Why is there no return value specified here? All right. Conceptually, you would really expect this to be like returns a point, return something of type point. And this is just one of those strange conventions that because when we call this constructor, Python is sort of doing some special work to wrap around this our own definition here. Like it's doing some legwork on our behalf to set up that space in memory without us knowing exactly what it's doing. And then it's doing some work to take, like there's no return value here, right? But since we have a reference to that object, it's going to return it for us. And so constructors are just sort of these weird beasts in just about every programming language you'll encounter that feel a lot like methods and functions, but are slightly different. And the reason they're slightly different is because they have a single purpose use, right? And their single purpose use is to initialize an object. But you'll notice that the same constructor can be called multiple times in the course of evaluating a program, right? So as anytime you construct a new object, its constructor is going to be called, and in the course of a program, you might construct hundreds of millions of the same type of object. But for a given object, the constructor will only be called once individually, right? So init will be called once, and then your object is ready to go. But how can we add some capabilities to our class? Let's add the ability to invert X and Y, effectively to flip X and Y, or to swap these two values, and add an example of a method, right? So down below the constructor, typically you'll see when you organize your attributes, your constructor, and your methods, it's common to list your attributes first, and then your constructors, and then your methods. And it kind of makes sense logically, right? The attributes tell you, hey, this is what any object of this class is going to be made up of. A constructor is here's how you get started using an object of this class. And then the methods are here's what you can do with it. Here are the operations that you can carry out on it. So let's imagine an invert function. It's going to have a self parameter and it's going to return none, right? And this is effectively kind of like a method that feels a lot like a procedure. It does have this special self keyword, and we're going to come back and talk about what exactly that means. So if we want to swap X and Y here, why don't we just go ahead and say, okay, we have temp, which is a float, and it's going to be assigned self.x. And then we're going to say self.x is assigned self.y, and self.y is assigned temp, right? And there's no return statement here, right? Now, when we were defining functions before, you tended to put two spaces, two new lines between each function because they're conceptually separate from one another. When we're defining, attributes and methods and constructors in a class, because they're all sort of grouped together and related to that same class, it's convention to only have one new line between them. Right? But this is defining a method, and we're going to look at how we call this method and what it means to have a method defined and called in just a moment. But let's go ahead and add a doc string here. Invert the attributes swap of the point, right? And maybe I'll add method to be sure that we're documenting invert, method to invert attributes of the point. I'm just going to try and keep this a little bit shorter so that the text doesn't go too far into the diagram. Okay, so we've defined a method here. How do we call a method? How do we make use of this? Well, let's try adding a method call. And the good news is you've actually been using method calls this whole semester. When you say things like, some list.append, that's a method call, or some list.pop, that's a method call. So here we can say a.invert. And there are no parameters besides self defined for invert. We'll talk about what that means in just a moment. So there are no arguments that we need to give it. And one of the sort of magical things about object-oriented programming is, well, what is self and how does that come to be? Oops. So let me see if I can get more of this onto the screen. All right. At this point, I think it makes sense to go ahead and try running this to convince ourselves that this method is actually called, and then we'll take a look at, well, what actually happened in order to process that method call. What does it mean for there to be a method call, and what is self when we're talking about a method call? So when we run this program, we started out with X being 4 and Y being 5. what we expect is that X will be 5 and Y will be 4. So we'll see 5, 4 printed instead, right? Just to see that this works, 5, 4, all right? Great. I want to just, okay, that all fits on my screen. So great question. The question is, how come init was automatically called, but invert we have to call explicitly? The gist of it is, we need a way of setting up a new object. And you could imagine maybe having to say something like point dot init or something like that, right? And that, you can't do that. You could imagine a world where you say, okay, the name of the class and then dot and then whatever method you're calling, and that would be the constructor's name. It feels, most programming languages have sort of settled on this convention that when you make a function call where the name of the function is actually the name of the definition of a class, we're going to call a constructor, right? And then you've got this problem of, well, what do you name the constructor? You know, there are languages that actually call the name of a constructor, which I actually kind of like. Python chooses init, which is nice and short. This is initializing the object. Other languages have other conventions. This process of setting up space and memory and keeping track of, well, what have I allocated and not, and some other concerns, is the programming language's responsibility. And that's one of the features of the Python language. We're not having to do that ourselves. We're relying on this ability to call a constructor and have some space and memory set up for us. With method calls, there's actually less magic going on. And when we call a method, it's like we're calling a function. We're directly calling into that code. Whereas with point, as I mentioned, there is a little bit of magic. And we actually call this auto magic. So this is automagically called. And we'll see there are some other automagical methods in Python as well that are super handy and valuable, that tend to be used in just very common circumstances. And it's just so common when you want to construct a new object to be able to work with it, that there are these conventions that exist. All right, so let's talk about what happens when we call a method like invert. I can barely fit that all on my screen. And I'm going to just modify my diagram here just a bit. Assume that we had just called the point init constructor for A. We have it in memory. And I'll allude to that with, a frame here. But I'm not going to keep those details there. What I want to do is say, okay, imagine we just finished line 21. We printed A, which is kind of a nonsensical thing to print at this point in our program. And now we call this method, all right? So the line that we're about to process is a.invert, right? Before we do that, let's just go ahead and put some terminology on this. This is a method call. And this is a method definition. Right? So invert is the definition of this method, just like we have function definitions, we have method definitions, and the call is saying, hey, actually go make use of that. But you'll notice there's a little bit of a difference between how we call a function and how we call a method. A method has the name of an object preceding the dot that comes before it, right? So a.invert, we're saying, hey, a point object, I'm calling your invert method. It's like we're directing this instruction at the object A. And that's going to be important, right? With a function call, we would just say the name of the function and then give it the arguments. With a method call, we're giving the name of some object. Here it's the variable A is a point object or a reference to a point object, followed by a dot and then the method name. right? So when we go to process a method call, we first need to ask, well, okay, what is the object? What is A? So A is a reference to this point object, right? So A is a point. And then we need to ask, does the class point even define a method named invert? And so we look inside that class definition and we say, okay, yeah. There's an invert method. So we can set up this call. If we had arguments here, we would need to go check out those arguments matching up with parameters. But here, there's no arguments or parameters in this method. We're just trying to call a very simple method, right? But there's this funky self business, right? So let's talk about what self is as we set up the frame for this method call. So just like we saw with the init frame, here we're calling the invert method of the point class. You could imagine other classes having a method named invert. So to be sure in our diagram, we know which invert we're talking about. I'm going to say point is the name of the class and hashtag invert. That's the name of the method we're calling, all right? The return address is line 23. And now we need to set up our parameters. We have this self parameter. This is a special one, right? Special keyword. When we make a method call, self is going to be assigned a reference to the same object the method was called on, right? So let me break down that a little bit. So invert is the method, right? And that method is being called on A. A is a reference to this point whose X is 4 and Y is 5. So what self is going to be is also a reference to that same point whose X is 4 and Y is 5, right? And this is sort of the magic and the beauty of method calls. And this is also why this whole paradigm is called object-oriented, because notice the object is coming first. We're sort of orienting our program around, okay, let's talk about object, and then what do we want to do with that object? Well, our object is A, and then we want to invert it. And we think of this as sort of the difference between our subject and our verb, right? Our noun and our verb. So our point, our subject is A, and then our verb is invert. This is the action we're trying to carry out on A. And when we go to set up our frame, Python behind the scenes is automatically saying, okay, well, self in this method call is going to be assigned a reference to this point whose X is 4 and Y is 5. Question came in, which is, do method calls permanently change the object? Well, that's a great question. So let's finish this out and then see what the resulting code beneath looks like, all right? So here, this is a method call just like any other function call. So we need to set up a variable named temp. And temp is being assigned self.x, all right? So self.x is 4. And then what we're saying is self.y is going to be assigned to self.x. So self.y is 5.0. And that's being assigned to self.x. So self.x is going to be 5.0. And at this point, we kind of see why we need to have this temporary variable when we're swapping two values, because now both of our x and y are 5.0. But we stored, what the previous x was in our temporary variable. So now we're saying temp, which is 4.0, assign that to self.y. So self.y is now going to be 4.0, right? This is a function, or sorry, a method that returns none. So my return value is going to be none. And, this wasn't used as an expression, but we're going to go back to line 23. We just finished this line, and now we're ready to continue on at this point. And so the question that came in is, have we permanently modified, have we permanently mutated this object? Did we just actually change its X and Y properties or attributes? Yes. So you're given a reference to the same object that you called that method on, and we just mutated it. And if you think about this, you've actually seen this, and you're pretty comfortable with this idea when it comes to a method call on a list. When you say, list.append some value, you're changing that list, right? When you say list.pop some specific index, you're removing that index from the list. And same with what we've seen in dictionaries. So when we call methods in this way, that self reference is able to modify the attributes of the object that it's given a reference to, right? And so what's kind of neat about this is if we were to continue on, and we tried printing this out, we did convince ourselves that this worked. But with B, we could also say, B.invert. And just the same, this would call the invert method on object B. And in this frame, if we were to diagram this out, self would have been bound to the same object B was, right? And that kind of makes sense. Like here we're saying, hey, I want to invert A, and here we're saying, I want to invert B. And we're directing this method call at these specific objects. Right? So let me throw this diagram back up and take a look at questions. All right. In the absence of questions right now, there's one other special magic method I want to leave you with. And a great question just came in, but I'll end with that one. Just to bring this full circle, one of the things that we started with was this idea that, hey, it's common that you want to represent a point as, the string 4, 5, which is the X attribute followed by the Y attribute. And when we used the, when we printed A, it printed like this sort of nonsensical point at some memory address that wasn't very useful. So let's look at one other special method that is another what we call a magic method or a special built-in method. That's called repr, and it's short for representation. And the idea of the repr method is it's one that, hey, it's pretty common when you have an object, you'd like to be able to represent it as a string. And so this is saying, how can we represent this object as a string? And what we want to do is just return the string that is, self.x, comma, self.y. And I'm using an F string here, right? And so I'm going to call this the magic method to represent object as string, right? So we added this repr method, and I'm going to try adding an explicit call to it down on line 26, right? So print a dot, and then let's call repr. Right? So this is saying print the result of calling the repr method on the A object, right? And what is repr going to do? Well, it's a very simple function, and it's just going to give you back the X and the Y in a string where it's X comma Y, just like we had in our opening example. Right? I'm going to leave this print B down here on line 36 as is, right? But I want to show you what happens when we run this. So remember, where we're coming from is when we printed B before, it printed this nonsensical thing. And when we printed A, we just replaced this, what was going to be here, with the a.repr method call. So I'm going to run this again. And notice that when we printed a.repr, the result of calling this method, we got 4, 5. And so we did successfully call this method. And something kind of neat happened when we tried printing B. Notice that it actually used that same method, and we didn't have to go and call repr ourselves. We'll talk more about magic methods, including this repr method, but there are some places where it's so common. So what we're mentioning here is this is the same as print A. It's so common that you want to be able to represent an object as a string that there's this built-in method that if you define that on a class and you print an object out, you're telling Python, hey, for this class, here's how I want you to here's the method I want you to call in order to know how to represent this object as a string, right? Let me take some questions. So is a defined method call accessible to all objects of the class? Yes. So when you define a method in a class, any object of that class now has that method associated with it, and you can call that method on it, right? So just like we said, a.invert because A was a point, well, we could call b.invert because b is a point. Any point object, we can say b.invert, and that method is going to have meaning because it's defined in the class. Just like with lists, every list that you used was an object of type list, and it had a built-in append method and a built-in pop method. Strings have methods like changing to lowercase, uppercase, things like that. When you define a method in a class, all objects have that method associated with it. And this is one of the benefits of classes and methods over plain old functions, right? Now we don't have to worry about, did we import this thing that's related? Did we import all the correct functions? When you have a class that has all of the helpful methods defined that you need on it, as soon as you import that class and start using that class and objects of it, you've got access to all of its methods. There's a question of, can you summarize the difference between constructor calls and method calls? That's a great question. Constructors are called when you call a function whose name is the same name as a class. And what happens here is we establish a brand new object in memory. And if we define a custom constructor like we did at the top, then we're going to go ahead and set up and initialize its attributes so that it's ready to go. And we have it's much nicer to work with a class that we can construct and have some meaningful values in its attributes straight away. A method is like a capability of an object, right? So when we defined a method, we now gave every point the ability to have this invert capability. And now you can invert any point. With methods, you might call them multiple times on the same object. Like if we could print, a.invert, we could print a here, we could call a.invert again and print a again, but you can't call the constructor twice. The constructor is intended to be called once per object. That's what establishes this new object in memory. And methods are how you interact with and perform operations on objects. And we'll be continuing to explore this terminology and these concepts in much more depth asynchronously on Thursday, and then in this unit. This is a first pass at these concepts, and they are all related to one another, and we'll continue getting more depth on them. Do methods have more arguments than self? Yes. So it's now 4:45, which is the end of our official time. So if you need to hop off, great work today following along. And we'll be getting more practice with this as we move forward. But let me keep moving through these questions in the time after. So we could have additional arguments to our methods and parameters. Let's imagine, just as a quick example, we could define a move up method, and you would have self and some delta y amount. Right? That would be a float. And let's say this is effectively like a procedure method where it's not going to return anything. It's just going to move the y attribute up. And move up is going to say self.y is increased by dy, or the delta y. Increase the y attribute of an object. Okay. And so you can define additional parameters on methods. If we wanted to call this method, and let's say, okay, a.moveUp. Here we're going to see there's an error. Okay, we need to actually give an argument that corresponds to dy, and let's say we're moving it up by 10.0. All right, so we inverted a, so 5 and 4, so y was 4 after that inversion, and then we move y up by 10, so we expect 14 to be the y component after this, and let's just see if this works. Sure enough, 5, 14 is the outcome there. So we will see it's very common to define methods, just like we have this constructor that had more arguments and more parameters than self. So that means we need to provide arguments at the call. And that will be something that's commonly useful. Just in these first few examples of methods, we didn't have any parameters, and that led to very simple method calls. Why would you call repr when you could just print a? You typically never would once you're comfortable with this. And I should add a note of that. Typically will not do this. conventional to just print A, right? The only reason I included this is to sort of convince you that this is just a method. You'll notice that it is kind of special because those double underscores, should set off some, when you're working in Python, some flags in your head to say, hey, there's something special here. At the end of the day, it's just a method. It's special because you don't have to call it when you try and use this object as a string. And that's kind of neat. And this is actually a very common idea in many programming languages as well. But typically you wouldn't write a.repr. Typically you would just print A. That's one of those things though that the first time you see it can feel very confusing. To confirm, you only call a constructor once per object, but could still call a constructor more than once in a program. Yes, so for the object A, we called its constructor once. That's what brought the object that A is bound to into existence. The object B, we called this constructor once for B, but that same constructor is being called multiple times, right? So the key distinction there is once you've constructed an object, you're not gonna like reconstruct it using the constructor. But you can call a constructor multiple times. Each time you call a constructor, you get a brand new object on the heap to begin working with, and you have a separate instance of that class available to you. All right, these were great questions today. Thank you all for following along. We'll have more content on this. This object-oriented programming takes some time to get comfortable with, but hopefully the work that we've put in getting comfortable with memory diagrams helps bring some of these concepts, which without memory diagrams can feel very nebulous together. So I hope you all have a wonderful rest of your Tuesday afternoon. 4.5 weeks left of class. We've got the last day of class coming up in under 30 days now. So we're in the home stretch here. Thanks for all the hard work you've put in so far. And let's put in one last big push to get to the end. Have a great rest of your afternoon.